Before the 18th century, chemistry was, well, it was basically more magic than science. It was a world of alchemy, of mysterious substances and strange theories. But one man changed absolutely everything. So today, we're going to dive into how Antoine Lavoisier gave chemistry its laws, its language, and its logic, really building the foundation for the modern world.
So you'll often hear Antoine Lavoisier called the father of modern chemistry. But that's so much more than just a cool title. It points to a fundamental shift he created. See, the thing is, he didn't just discover new stuff. He created a whole new way of doing chemistry, one built on relentless precision and measurement. And that, right there, was the engine of his entire revolution.
Okay, but to really get why he was such a game changer, we have to take a step back into the 18th century. The world of chemistry he walked into was, to put it mildly, a confusing mess. I mean, can you imagine trying to do science when the main theory for fire involved some invisible thing called phlogiston, and chemicals had these wild names like sugar of lead? It was total chaos.
All right, so here's the game plan for how we'll walk through Lavoisier's revolution. We're going to start in that wacky world of phlogiston, then we'll uncover the real truth about fire. From there, we'll establish that matter is never lost, build a whole new language for chemistry, and finally, see how he literally rewrote the textbooks. All right, let's jump in.
Okay, first up, let's talk about the world before Lavoisier. The single biggest idea in chemistry, the one that explained pretty much everything from a burning log to rusting metal, was this mysterious substance called phlogiston.
So the theory was actually pretty simple, right? Anything that could burn was supposedly packed with this stuff called phlogiston. And when you set it on fire, you were just letting the phlogiston out. It seemed to make sense, but there was a huge problem, a fatal flaw that just didn't add up. Sometimes, after something burned, it actually got heavier. Now, how does that work? This is the puzzle Lavoisier set out to solve.
And it wasn't just the theories that were a total mess. The language itself was baffling. I mean, just look at some of these names. Sugar of lead, oil of vitriol. They sound like something out of a fantasy novel, not a chemistry lab. They tell you absolutely nothing about what the chemical is actually made of. How can you build a science when you can't even name things clearly? This was the chaos Lavoisier knew he had to fix.
And this is what brings us to Lavoisier's first big revolutionary act, tackling the mystery of fire itself. He was completely determined to figure out what was really going on when something burned.
So, what was his secret weapon? Was it some newfangled chemical? Nope. It was something much simpler. The balance scale. Seriously, Lavoisier was obsessed with measurement. While all the other chemists were describing colors and smells, he was weighing everything, before reaction and after reaction. This one simple shift, from just describing things to precisely measuring them, well, that was the key that unlocked modern chemistry.
And this obsession with measuring led him to his most famous experiment. Okay, so first, he takes a metal and weighs it, very carefully inside a sealed glass jar. Then, he heats it up, and the metal turns into this powdery stuff. He weighs the whole sealed jar again, and the weight is exactly the same. But, and this is the genius part, when he breaks the seal, you hear a whoosh of air rushing in. And when he weighs just the powder inside, it's heavier than the original metal. The takeaway was just undeniable. Burning wasn't about losing phlogiston, it was about gaining something from the air. And we absolutely cannot tell this story without talking about his indispensable partner, his wife, Marie-Anne Pauls Lavoisier. She wasn't just an assistant, she was a full-blown scientific partner. She actually learned English just so she could translate the work of his rivals. She took all the meticulous notes during these world-changing experiments, and, being a talented artist, she drew these incredibly detailed diagrams of his lab equipment so other people could see exactly what he was doing. Really, this whole revolution was a team effort, through and through. So, armed with this mountain of hard data, Lavoisier could finally, officially, declare the death of phlogiston theory. Combustion wasn't some mythical substance escaping. No, it was a chemical reaction, a combination with a specific active part of the air. He gave this gas a name, oxygen. And just like that, the world of chemistry was changed forever.
But his obsession with that balance scale, well, it led to something even bigger, even more fundamental, a principle that would become the absolute bedrock of modern chemistry.
This is what led him to what is, without a doubt, the most fundamental rule in all of chemistry, the law of conservation of mass. By using his balance to track every last speck of matter in a closed system, he proved it. In a chemical reaction, matter isn't created and it isn't destroyed.
The atoms they just get rearranged. Nothing is ever truly lost.
He even took this idea outside of pure chemistry, looking at something like the fermentation of grapes into wine. He carefully weighed the starting grape juice and then showed that its mass perfectly equaled the mass of the alcohol and the carbon dioxide gas that were produced. And that simple equation you see? That's basically one of the very first balanced chemical equations ever written down.
Okay, so at this point, Lavoisier has a new theory for fire and a new fundamental law for matter. But he realized something crucial. To really build a new science from the ground up, you need a new language. Those old, confusing alchemical names just had to go.
See, he was really into the ideas of philosophers like Condillac, who basically said you can't think clearly if your words are a mess. It makes sense, right? If the names of your chemicals are illogical, the science itself is going to stay illogical. So he got together with a team of other top French chemists, and they built a whole new system for naming things. The rules were brilliant because they were so simple and powerful. They used Greek and Latin roots, but most importantly, a substance's name now told you what it was made of. All of a sudden, if something had oxygen in it, you called it an oxide. Simple. A salt made from sulfuric acid became a sulfate. The language itself finally contained useful chemical information.
All right, so Lavoisier's got the old theory busted, he's got a new law in place, and he's created a whole new language. What's the last step? You've got to put it all together in one place and teach it to the world.
So in 1789, he published this book, The Elementary Treatise on Chemistry. And look, this wasn't just another book. This was basically the founding document of modern chemistry. For the very first time, it put his oxygen theory, the law of conservation, and the new language all together into one single logical system.
And inside this book, he gave the world a totally new practical definition for what an element is. He said forget all that ancient philosophical stuff about earth, air, fire, and water. For him, an element was super practical. It's just a substance you can't break down any further in the lab. That's it. This moved chemistry out of the realm of philosophy and planted it firmly in the real world of empirical laboratory fact.
So let's just do a quick recap of the whole revolution, right? His oxygen theory didn't just replace the myth of phlogiston, it explained what fire and even breathing really are. His law of conservation of mass became the foundation for all quantitative chemistry. His new chemical nomenclature gave scientists everywhere a universal language so they could finally understand each other. And his new definition of an element gave chemistry its real empirical building blocks.
When you step back and look at it, what Lavoisier did was incredible. He took a field that was basically a collection of old recipes and superstitions, and piece by piece, he turned it into a real, structured, predictive, modern science. It's just an amazing story, right? It shows how one person's obsession with precision and logic can totally flip our understanding of the world on its head. I mean, Lavoisier tore down a scientific truth that had stood solid for 100 years. So it kind of makes you wonder, doesn't it? What scientific truths that we hold so dear today are just waiting for their own revolution?